So for the last video, we're going to talk about some other ideas with community ecology, and we're going to talk about disturbance. Now, disturbance can be any event: storm, fire, flooding, drought, human activity. So here we have human activity. We have a storm has come through and knocked down trees. This is California on a daily basis, unfortunately. They talk about we have summer, 2 days of winter. Now we have fire season. That's kind of our seasons here, and we're almost moving into constant fire season, which is real scary. So these are all forms of disturbances. All right, so there's this intermediate disturbance hypothesis that is newer, and one of the problems is we really haven't done well in the way we manage things. Especially with the national parks, Yosemite, Yellowstone, we've had issues with fires, and the fires have really fires and drought, I guess, so combination have really devastated some of our national parks. The problem was we were in this mental state that we needed to save the world, and we tried to save these parks kind of as snapshots. So we wouldn't let them burn. We wouldn't let them go through any of these natural cycles. So what we got was these aging trees that were not well managed. And we also had some undergrowth underneath. And so what would happen is, what you would expect is to have these fires go through and clear out the underbrush. They would be small, kind of slow, and just kind of move through. And the trees would deal and live through that. And what happened though is when you completely shut that down, we introduced a huge amount of kindling basically underneath all this dead material, and then it lit. And when it lit, it burned very slow and very hot. And then we have these massive fires, which take on all kinds of biodiversity. So what we have found, and here you can see this is a burned area, and within a year, all of this growth has come back. Now, it's obviously not the trees, but this is the idea of succession we'll talk about, where things start to move in and become better. Now, what happens a lot of times when we talk about fires, and everybody's like, "Oh, fires are bad," and they're not. They're actually a natural phenomenon that needs to happen for regrowth. So the idea behind this thing is, it's better to have a little bit of disturbance so things can adapt and change, so you don't get one species kind of taking over the world. Too much devastation, things can't change. We have lots of invasive species and we have issues. Not enough change, you end up with what we call these climax communities, which are fine, except for you really don't want to be there, like even Chaparral, our local desert stuff. It becomes very dense, very heavy, very big, and with very few species. And so chaparral, coastal sagebrush, those are always meant to burn. Those communities evolve with fire, and they have a 10 to 15 to 20 year cycle in fire, depending on who you talk to. And we've suppressed it for 100 years. So all we have is fuel. And then once it gets all torched, that's not good for anybody. So the idea is intermediate disturbance hypothesis. It's better to kind of be in the middle, to have a little bit of disturbance, have a little bit of adaptation, allows other species to get in there and kind of foot themselves. And so that's what you want. All right, let's talk about succession. Succession is moving from one type of community to another. And there's two types: primary succession, which is really shown in number 1 here, where you have a volcanic island that's come out of the ocean, or a glacier has just scraped everything dead and sitting on land, and then that eventually melts back and new land is exposed. And so that would be what we call primary succession, where you end up with very small plants, grasses, things like that moving in. And then it will move on to eventually secondary succession, where one type of stage is replaced by another. So here we show the pioneer stage, which is primary, and then you have the dryas stage, which would be secondary. And then alder would also be, they don't usually really tertiary succession. It's a type of secondary. And then the spruce stage, which would be the mature climax community in this area. And that, you know, and that works all the places we have. Ponds will eventually fill in with sediment, will eventually dry up, and they'll become grasslands. Eventually shrubs will move in, and then even trees if conditions continue. What keeps a grassland open or a chaparral area open or these things is fire and large predator, large cattle are the two things that really keep grasslands open. Not cattle, but herbivores are what keep grasslands open, because the shrubs are trying to get in there, and as long as there's enough of nutrients, they can. But with fire and large grazing animals, that will keep grasslands open. All right, these last few things that affect community diversity, we're going to spend more time on them on the next part. They threw them in this chapter, and I kind of was trying to decide whether to include them, and I thought it's probably not a bad idea to introduce this idea here, but we're gonna talk about it for the final. So one is latitudinal gradients. Wallace and Darwin both figured this out. Depending on what latitude you live at, will determine how many species there are, and we'll talk about this. It turns out at the equator is where most species are, got the greater numbers, and then as you move away from that, you will see that you get less and less. And this really, they're linking this picture down here on rainfall, where, you know, tropical rainforests are right there at the equator. And so that's where you get most species. So yeah, so latitude on the Earth is one, and we'll talk about this more. Area effects is another, and this is size. And we talked about this with island biogeography a bit, and we'll talk about it more. And the idea here is that small islands do not have as many species as large islands. So area makes a difference. And here's the island biogeography idea, and we'll again talk about this more. Not only is a small island, it's worse than a large island. Large islands will have more species. It's also, you know, how far away are they from being resupplied with new species? So how far off is that island? So a small island far away from the mainland is the worst you could possibly have. A large island near the mainland would be something better. All right, and with that, we will stop the share and stop the recordings for the week.